Welcome to a webcast produced by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Algebra series and concerns solving quadratic equations by factorisation. This guide looks at quadratic equations and gives a basic technique for their solution. The solutions are described graphically as particular points on the corresponding quadratic function. Introduction. Before reading this guide, you should read the study guide, Quadratic Functions, to familiarise yourself with the language used here. You should also read the study guide, Factorising Quadratic Expressions, to understand the technique of factorisation. Every quadratic function takes the form y equals ax squared plus bx plus c. And this equation is known as the general form of the quadratic function. When you solve a quadratic equation, what you're doing is finding the points where the quadratic function crosses the x-axis. Crucially, at every point on the x-axis, y takes the value of 0. Setting y equal to 0 in the general quadratic function leads to the general quadratic equation. By setting y equal to 0 in the function above, you get ax squared plus bx plus c equals 0. The solutions of this equation give the points at which the graph of the corresponding function crosses the x-axis. In mathematics, the solutions have a special name and are known as the roots of the equation. There are a variety of methods for solving quadratic equations. See the study guides, Solving Quadratic Equations Using the Quadratic Formula, and Completing the Square. The simplest and quickest method of finding the roots is by factorising the quadratic expression on the left-hand side of the equal sign. Quadratic equations with no constant term. Quadratic equations with no constant term are straightforward to solve. In other words, if the number represented by c in the general equation is 0, you have ax squared plus bx equals 0. There is a common factor of x in each term on the left-hand side of the equation, and so the equation can be factorised using simple factorisation. See the study guide, Simple Factorisation. So the equation becomes x multiplied by ax plus b equals 0. Importantly, you have two things multiplied together on the left-hand side of the equation, x and ax plus b. In order for x multiplied by ax plus b to be equal to 0, either x or ax plus b must equal 0 themselves. You can write this mathematically as x equals 0 or ax plus b equals 0. The first equation gives a root immediately as x equals 0. The second equation gives a second root by rearranging ax plus b equals 0 for x. After the rearrangement, you find that x equals minus b divided by a. So, for a general quadratic equation with c equals 0, the roots are x equals 0 and x equals minus b divided by a. If you are given a and b in a particular question, you can write the two roots down immediately. Here's an example. Where does the function y equals 6x squared minus 5x cross the x-axis? This question is exactly the same as solve 6x squared minus 5x equals 0. Note that a equals 6 and b equals minus 5. By simple factorisation of the common factor x, you can write the equation as x multiplied by 6x minus 5 equals 0. And so x equals 0 or 6x minus 5 equals 0. You can find the roots by either rearrangement or by using the formula above. The roots, and hence the points where the function crosses the x-axis, are x equals 0 and x equals 5 divided by 6. Quadratics which can be factorised by inspection. If you decide that the quadratic equation you're solving can be factorised by inspection, then you may use that method. It is extremely useful to identify these equations, as factorisation by inspection is quicker and easier than other methods for finding roots. As your experience of factorising by inspection increases, you may be able to factorise more complicated quadratic expressions. Here's an example. Find the roots of y equals x squared minus 5x plus 6. This is the same as the question, solve x squared minus 5x plus 6 equals 0. This equation can be factorised by inspection to give x minus 2 multiplied by x minus 3 equals 0. You have two terms on the left-hand side of the equation, which when multiplied together equals 0, and so either x minus 2 equals 0, or x minus 3 equals 0. Rearranging the first equation for x gives x equals 2, and rearranging the second equation for x gives x equals 3. The two roots are x equals 2 and x equals 3. On the function graph, the roots represent points where the function crosses the x-axis, here at x equals 2 and x equals 3, as can be seen in the graph below. You may find that you have identical brackets after factorisation by inspection. This represents a function which touches the x-axis at a single point. In this case, both the roots will be equal to the same number. Here's an example. Where does the function y equals x squared minus 6x plus 9 cross the x-axis? By factorising the corresponding quadratic equation x squared minus 6x plus 9 equals 0, you get x minus 3 multiplied by x minus 3 equals 0, which is more simply written as x minus 3 squared equals 0. So the root is x equals 3, and the quadratic function just touches the x-axis at x equals 3, as shown in the graph below. Further guidance and information. If you have any further questions about algebra or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592 761 or email dos.help@uea.ac.uk or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.